Greetings everyone. Today we're going to explore finding slant asymptotes. A couple of things before we get started. We need to remember that slant asymptotes occur when the degree of the numerator is exactly one bigger than the degree of the denominator. When this occurs, we end up with a slanted line that functions as the graph's asymptote. Again, cases like this have to be 1 degree bigger. So if my degree is 3 in the numerator and 2 in the denominator. If we have a degree of 3 on top and a degree of 1 on bottom, that is a different case that we're not going to explore now. So we're concerned about 1 degree higher when it's top heavy. So to find the equation of that asymptote, we're going to go back to the long division that we learned a while ago. It didn't seem to have very much of a purpose at the time, but now we are going to use it in order to graph. So quick review of dividing. In this case, in this function, rational function, I can see I have a degree of 2 and a degree of 1. So I'm going to go to long division and I'm going to divide. Yes, in some cases you can use synthetic division, but I'm in the habit of always using long because there's no restrictions when I use long division. So first of all, I see that to go from x to x squared, I need a 1x. If I multiply that out, x squared plus 5x. Remember that you subtract because that's what makes the first term cancel. I have a negative 6 subtract 5, which is negative 11x. I'm going to bring down my 7. In order to get to negative 11x, I need a negative 11. So negative 11 times x, negative 11x. Negative 11 times 5 is negative 55. We're going to subtract, so those first terms cancel, and I'm going to end up adding here, and I'm going to have a remainder of 62. So my final answer here for this long division would be 1x minus 11 plus a remainder of 62 over the divisor. All right, let's take a look at another quick example when I have a leading coefficient on my numerator and denominator. So first I want to start off again by setting up my long division. So here's a good reason why we want to stick to long division because of that leading coefficient. Remember that if you're missing a term, you want to fill in with a 0, a placeholder. So to start off, I need to get from 2x to 3x squared. How can I do that? That means, you guys, I'm going to need a fraction. So if I take 1.5 or 3/2 x, 1.5 times 2 gets me to 3x squared. 1.5 of 6 gets me to 9x. So yes, you might have to think of some fractions, okay? We'll talk a little bit more about how we should write that fraction in a moment. So I'm going to subtract. So I end up with a 1 minus 9, which is a negative 8x. I'm going to bring down that minus 2. To get from 2x to negative 8x, I need a minus 4. So minus 8x, I'd end up with a, looks like a minus 24. If I subtract negative 2 minus negative 24, that's going to add, and I have a remainder of 26. So if I was to write this out, my suggestion is, because our goal is this linear slant asymptote, okay? So we want to think slope-intercept form. We want to think rise over run for our slope. So the best way to write our answer is actually going to be as 3/2 x minus 4. I do have a remainder of 26 over the divisor, okay? This, though, I know how to graph that. Y-intercept of negative 4 and a slope of rise 3, run 2. So this slope, it's okay that it's a fraction. We can graph that pretty easily. And it makes sense for a linear graph. The remainder, we don't have to worry about that when graphing. Okay, so algebraically, we should see that, but unnecessary on the graph. Okay, so we won't worry about that right now. All right, let's apply this completely in a full graph. Let's go through all the process of graphing this function, okay? So I'm going to go through our notes, go through our list. The first thing we need to do is to simplify. So I need to see if I can factor that numerator and that denominator. So I end up with an x, a 3 and a 1, a minus 3 and a plus 1 over x minus 2. Okay, so nothing cancels, but it is simplified, which will be helpful. Let's talk about any holes we might have. I didn't cancel anything, so guess what? There's no holes in my graph. Let's talk about roots or solutions. If I set my function equal to 0, then I'm worried about those numerators factors, right? If I set those equal to 0, I end up with solutions of x equals 3 and negative 1. So on my graph, I know I'm going to cross at 3 and at negative 1. Let's talk about vertical asymptotes. When is my graph undefined? Well, let's take a look. When is my denominator factors equal to 0? When x equals 2. So I need my vertical asymptote at x equals 2. So I'm going to graph as we go through the process. All right, next let's talk about tangency and togetherness, okay? Tangency is when you have the same factor on the top. And I don't, okay? So tangency, don't have to worry about that. Non-existent, NA, nothing we have to be concerned about. Togetherness, do I have the same factor on the top, or excuse me, on the bottom in the denominator? And I don't, okay? So I don't have to worry about that either. Remember, togetherness means that at the asymptote, we meet at the asymptote and shoot up the asymptote at the same time. So like shoots up to the top, shoots up to the top. It's almost like those graphs are going to meet, but that asymptotal wall is in the way. Okay, that's what togetherness means. Talk about end behavior. All right, so here's where this comes into play. My degree is 1 larger in the numerator than it is in the denominator. So I need to divide. Okay, so I'm going to do the division over here where I have a little more space. X squared minus 2x minus 3, x minus 2. So to get to x squared, I'm going to need an x. Gets me x squared minus 2x. Draw a line. Hey, and both of these cancel. I'm left with minus 3. Nothing times x will get me to minus 3, so that's actually my remainder. So I have a negative 3 over x minus 2 as my remainder. So what part of this do I need to include? The linear solution that is remaining. So my slant asymptote is going to be y equals x, which is a perfect diagonal line, right? I start at 0 and I have a slope of rise 1, run 1, rise 1, run 1, rise 1, run 1. So I should have that sort of parent function for a linear graph. All right, let's take a look and see if we cross that slant asymptote, meaning where does that function cross that slant asymptote? So we're going to take our simplified function and we're going to set it equal to the slant asymptote. We haven't done that yet, okay? So I'm going to take x minus 3, x plus 1 over x minus 2, and I'm going to set it equal to my slant asymptote, which is x over 1, okay? So if I cross multiply this, I'm going to have x minus 3, x plus 1 equal to, I'm going to distribute right away, okay? Which means actually having that simplified version's not going to be helpful. I'm going to actually FOIL that back out, and I'm going to distribute this. Now, if I move everything to the other side, if I subtract x squared, they go away. If I add 2x, it goes away. I'm left with negative 3 equals 0. Not a true statement. Therefore, I'm not going to cross the slant asymptote, okay? So I have this sort of crisscross of asymptotes, so I can make an assumption that I'm going to have two curves follow along those asymptotes. Let's quickly do the y-intercept, right? That's always the easiest part. So my y-intercept is going to occur when x equals 0, so I end up with at 0, 3 halves. Okay, so at 0, I'm going to be at 1 1/2. I need the rest of the graph. Okay, you do not need a calculator. We need to start preparing to not have our calculator. Okay, so if I'm going to use this table, I'm going to do 1 to the left. Oh, let's do a couple to the left of my furthest left out. Let's do 1, 2, 3, let's do -4. See where that gets me. I'm also going to do +1 because I want to see if it comes up and approaches that vertical asymptote. I already have 1 to the right at 3. So let's also do 4 and let's say 6 just to jump ahead a little bit. So at -4, if I plug that in, I'm at 16. Just do a little bit of scratch work here. I'm going to be at +8 -3. So I'm going to be at 16 plus 5. It's going to be 21. -4 minus 6 is going to be -6. So let's see, 6, 12, 18, -3 point something, right? So at -4, 1, 2, 3, 4. I'm at -1, 2, 3, and a little bit. Oh, I'm right approaching that asymptote. That makes sense. I feel confident in my asymptote so far. If I plug in 1, I'm going to have 1 minus 2 minus 3. So let's see, that gets me to -4. Are we right there? If I plug in 1 in the denominator, I'd have 1 minus 2, which is -1. So I'd be at 4. Hey, that's nice and clean. At 1, I should be at 1, 2, 3, 4. That makes sense. I'm approaching that vertical asymptote. So now take a look at how this graph follows and never crosses and follows these points and then doesn't cross that vertical asymptote, which makes sense. We could probably make an assumption about the other part of the graph. Let's see. So at 4, if I was to plug in 4, I'd have 16 minus 8 minus 3. So I'd be at 8 minus 3, I'd be at 5. If I plug 4 in the denominator, I'd be at -2. So let's see, -2.5. That's easy. So at 4, 1, 2, 3, 4, I am at, a negative. That doesn't seem right? It's not along the asymptotes. Let me check my work again. 16 minus 8 minus 3, so that'd be 8 minus 3 is 5. Oh, 4 minus 2, you guys, that's a +2. What am I doing? This should be a +2.5. But 1, 2, 3, 4, I should be at 2.5. That makes sense. Okay, here's what I like, even if you can't use a calculator, your points should make sense with your asymptotes. Let's plug in 6 and see if we've gone even higher to approach that diagonal asymptote. If I plug in 6, I've got 36 minus 12 minus 3. So guess what? 24, 21. And then 6 minus 2 is 4. So if I plug that in, I'm at 5 and a little bit. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and a little bit. That makes sense. So that's going to curve along and follow that diagonal asymptote, slant asymptote, and this is going to follow the vertical asymptote. Okay. Let's talk about domain and range now, our last little piece of information. Hang in there with me, okay? Domain. Domain goes from -infinity all the way to the right to 2. It doesn't touch 2, there's my vertical asymptote, but it picks back up at 2 and goes all the way to infinity. I exist everywhere left to right except for at 2. So then my range, hey guys, my range is actually -infinity to infinity. Okay, because this is going forever down, and if I follow, this is going to go forever up, just slower. Okay, so my range is -infinity to infinity. All right, we've got one more example. Now, I'm not going to walk all the way through this. I'm just going to do pieces of it. So the rest of it, I do want you to fill in your notes and have that practice. Okay. So taking a look. To start off with, what we're concentrating on in this video is the slant asymptote. So I'm going to take care of that end behavior right away. Okay, so I see degree of 2 over degree of 1. I'm going to show that long division. You'll notice I'm missing a constant, so I'm just going to put a 0 there to help me remember that placeholder. So I need, let's see, an x first. X times x is x squared plus x excuse me, plus 1. Oh my goodness, plus 1x. There we go. If I subtract, cancels, careful here, a negative subtract 1. So I'm actually at negative 2x plus 0. Then I need a negative 2, which gives me negative 2x, and I end up with a negative 2. If I subtract, I actually end up with a remainder of 2. Okay, so we're worried about the linear part of that solution. All right, so I'm going to graph starting at negative 2, and I have a slope of 1. That is going to be my slant asymptote, diagonal line that I may or may not cross. I'm not quite sure yet. Okay, we want to carry that all the way through the graph. It is slanted as a line, so it does, that asymptote does go on forever. So I do want to include those arrows. Okay. I can already tell I'm going to have a vertical asymptote at negative 1, because that would make my function undefined. So now I can already see I'm probably going to have 2 pieces. In this case, I want you to figure it out, but it will not cross that diagonal asymptote. Okay. So next, I need to find some points. All right. Let's find our y-intercept. Why? Because that's the easiest thing to find, right? If I plug in 0 for x, I should end up with, I actually end up with 0 over 1, which is 0. So at 0, I'm at 0, 0. Okay. So I'm also going to plug in, let's do a 1 value. I'm going to plug in a 5 to shoot to the right a little bit, but I also need some negatives. So I'm going to go negative 2. That would be just to the left of the asymptote, and I'm going to go negative 5. So if I plug in 1, at 1, I would end up with 1 minus 1. Oh, wait a second. I end up at 0 over 2, which is also 0. Let's talk about that in a second. If I plug in 5, my hope is that it follows that slant asymptote. If I plug in 5, I'd have 25 minus 5, so I have 20 over 6. So let's see, 3 and a little bit. Okay, so at 1, 2, 3, 4, 5, I'm at 3 and a little bit. Perfect, that makes sense. So what this means, you guys, I'm going to follow this slant asymptote, but I'm also going to just swoop down below this a little bit and then come back up. If I also, for example, type in negative 0.5, it's going to be approaching this asymptote. Sorry, that should be a little straighter there. So that makes sense. I can do that. I can come below that x-axis a little bit. Negative 2. Let's see, we got 4 plus 2. Negative 2 plus 1 would be negative 1. So at negative 2, 1, 2, I'm at negative 6. 1, 2, 3, 4, 5, 6. Okay, that makes sense. They're diagonally across from each other. Let's try negative 5. Negative 5 would get me to 25 plus 5. So that would be 30. Negative 5 plus 1, negative 4. Okay, so that'd be negative 7 point something. All right. Don't need to worry about the decimal because we can't graph that exactly on these small graphs anyways. So at negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and a little bit. That makes sense. So that means I'm going to come up, I'm going to curve around, follow that vertical asymptote, and follow that slant asymptote. Okay, the graphs should make sense on these. Okay, if you're crossing asymptotes all over, if you don't see any kind of symmetry or sense in this graph, something's wrong. Okay, check your calculations, check all your steps. So again, on that previous example, finish that up on your own. The key thing is that slant asymptote. Yes, I know we can use a calculator on our homework, and I encourage you to check. Okay, do not rely on it to graph, because guess what? We're probably going to have a no calculator learning check, so be prepared for that assessment. Okay, use the acronym to help you remember all the steps. If you're not a step person, then just break it down. What does each piece mean? And you'll get that full graph and execute it correctly. All right. you have any questions, let me know. Scope out other video links, check out Miss Marcia's videos. And again, until next time, have a good one.